Okay, so in this video, I'm going to go over some of the analysis capabilities that are found in SNT. And you'll see that I already have SNT open. And the first thing we need to do is import our reconstruction. And you can do that either by going through the import menu in the main SNT dialog, or you can simply drag either a single SWC or a directory of SWCs either into the main dialog or into the path manager, and it will automatically populate it for you. Okay, so this is our reconstruction, and first I'm going to go over the analysis features that are found in the utilities menu. And the first one is quick measurements. And what that does is generate a table of summary statistics so you can get a quick idea of some of the quantitative properties of your reconstruction. Okay, so next we're going to go over shoal analysis. And if you choose the shoal analysis option in this menu, it'll bring up a help dialog which describes two ways of conducting shoal analysis on your reconstructions, and also the links shown in blue will take you to the plugin page and also some walkthroughs for more information. And the first way of doing this is a little bit more coarse, and all you have to do is hover your mouse over where you want the center of analysis to be, right click and choose shoal analysis at nearest node. But a more accurate way of doing this is to first select the path which contains the node where you want the center of analysis to be, then hold down Alt and Shift on the keyboard, which will snap your mouse cursor to the nearest node on that path, move to where you want the center of analysis to be, and press Alt Shift A, and that will bring up the shoal dialog with the center of analysis at that exact node. And the only option I'm going to go over here is the radius step size. And if you click preview, it will actually show the center of analysis with the concentric spheres expanding out of it. And you can choose your radius step size interactively. And this will help you better gauge sampling distance. So choose the step size that's best for your purposes and any of the other options, and click Run Analysis. And it will generate the shoal plot, which shows the number of intersections of your neuron with the concentric spheres. Versus distance from the center of analysis with the fitted curve shown in blue. And you can save this plot in the main Fiji dialog by going to File, Save As. And it also generates the shoal table, which has the same information but in table form. And there are also more resources. If you go to the option Preferences and Resources, under Help and Resources, there's links to more documentation as well as the source code. Alright, so next we're going to do Strahler analysis, which is another way of measuring the branching complexity of your reconstruction, similar to shoal analysis. And if you choose this option, it'll generate the Strahler plot, which shows the range of Horton-Strahler numbers that were calculated for your reconstruction, as well as the number of paths, branch points, and total cable length that has been associated with each Horton-Strahler number. And you can save this figure by right-clicking on it and going to Save As. And it also generates the Strahler table, which has the same information. And next, I'm going to go over the reconstruction plotter, but first I want to color code this reconstruction. And to do that, go to the Path Manager under Analyze Color Coding, and you can choose from a number of different metrics to color code your reconstruction. I'm going to choose Branch Order with the ICE lookup table, and whichever lookup table you choose will be shown in this color bar here. So click OK, and you'll see that it color-coded our reconstruction. And then I'm going to go to Reconstruction Plotter. And what this does is generate a plot, which is a 2D projection of our reconstruction. And you can specify the orientation along each axis. And there are also a number of different presets here. And if you go down to Render Final Colorized Plot, it'll generate a colorized version of this plot with the same orientation that we specified, with the color-coded metric that we chose for our reconstruction. And you can save this plot, do whatever you want with it, say make figures for publications, presentations, etc. Okay, so the last feature under the Utilities menu that I'm going to go over is Compare Reconstructions. And you can select two reconstructions in the File menu, and choose their colors individually, and I'll be comparing the OP1 and OP2 cells. And if you press OK, it'll bring both of those reconstructions up in the 3D reconstruction viewer. And it'll also produce the same table of quick measurements that we saw before, so you can get a quick idea of the differences between the two reconstructions. Okay, so we went over all the analysis capabilities that are found in the Utilities menu. Now we're going to head over to the Path Manager under the Analyze menu, which contains some more analysis features. And one of the big differences here is that analyses can be applied to any arbitrary grouping of paths, whereas the analyses in the Utilities menu would be applied to all paths. And you can select any grouping of paths by holding down Control while you click on paths in the Path Manager. And paths can also be filtered by any arbitrary text in the filtering toolbar down here. And also the advanced filtering menu contains more advanced text filtering options, as well as color filtering and filtering by morphology tags. And all of these features are detailed in the SNT user manual, which can be found at the imagej.net/SNT webpage. All right, so I'm just going to select the primary path for demonstration. And the first feature I'm going to go over is distribution analysis. And you can select from a variety of different metrics here. I'm going to choose node intensity, and this will generate a histogram of that selected metric. As you can see, most of them are in the 250 range, which makes sense since this is an 8-bit image, and it's a very bright cell, and it's the primary path. Okay, so the next feature is measure, and this is actually the same quick measurements function that we saw in the utilities menu, but this time it's only been applied to the path that we've selected. You can see that here. See, it's just one path with the same measurements that we saw earlier. And then the next function is convert to ROIs, and this allows paths and nodes of the reconstruction to be converted into ImageJ ROIs, which lets them be used in various image processing routines. And you can select which type of compartment you want to convert. Then it shows those selected compartments in the ROI manager. Okay, so next is plot profile. And what this does is it takes the pixel intensity values under each node in the selected paths and plots the pixel intensity as a function of distance from the beginning of the path. And it produces this nice plot here, which can be saved by going to File, Save As in the Fiji dialog. And there are many ways of adjusting and scaling and interacting with this plot. And one thing I'm going to show is that you can add fits and choose from a variety of different fitting functions. And also, if you press list, it will convert this data into a table, which can be saved as a CSV. So you can open it in Excel and any other similar program. All right, so the last feature I'm going to go over is skeletonize. And I'm going to run this on all of the paths, so I'm going to deselect all of them first. And what this does is it outputs a binary image, which is a topographic skeleton of any of the paths that you've selected. And you have the option to convert only segments that are contained in any ROIs that you might have created. And you also have the option to run the Analyze Skeleton plugin after conversion, so I'm going to do that. It brings up the Analyze Skeleton dialog. I'm not going to do any path pruning, so press OK. And see, it generated our skeletonized image. And similarly to the fills generated by the Fill Manager, these images can be used as masks in image processing routines. And you can save these images by going to File, Save As in the main Fiji dialog. You can also do that with the tagged skeleton image. And it also produces the table of results for the Analyze Skeleton plugin, which can also be saved as a CSV. Okay, so thank you for watching. And if you have any more questions about either the shoal analysis, Strawler analysis, or Analyze Skeleton plugins, I've included links to their respective plugin pages on ImageJ.net. Okay, thanks.